Yes, good morning students. Today we will discuss about parabola. In the last video we have seen the introduction of conic section. What is a conic section? How many types of conics are there? How they can be obtained depending on eccentricity. If E is equal to 1, it is a parabola. If E less than 1, ellipse. E greater than 1, hyperbola. E equal to 0, circle. E tends to infinity, a pair of lines. Also we have seen the important terminology of this chapter. What is axis, vertex, directrix, lattice rectum, focus, focal distance, double ordinate, etc. Okay, today we will discuss about parabola, which is a very most important chapter. Yes, parabola. Very simple. What is a parabola? See now, parabola is a conic. Parabola is a conic for which eccentricity small e is equal to 1. That's all. Simply the definition of a parabola. What is a parabola? Parabola is a conic for which eccentricity is 1. So I said parabola is a conic. Then what is a conic? We have seen in last video. Conic or conic section. What is a conic section? By the definition, it is locus of a point P. Conic section is a locus of a point P satisfying the condition SP by PM is equal to E. What is a conic section? Conic section is a locus of a point P satisfying the condition SP by PM equal to E. Parabola is also same conic, but for which eccentricity is 1. Therefore, I can say that what is a parabola now? It is also a locus. Parabola is also a locus of a point capital P satisfying the condition SP by PM is equal to 1. Therefore, for parabola, what is the condition? SP by PM is equal to 1. That's all. Okay, this is the parabola. Parabola is a locus of a point P satisfying the condition SP by PM is equal to 1 or simply SP equal to PM. Now we will see the standard form of a parabola. You take any subject, any topic, I believe that those should be studied in order, in a proper sequence. Then every chapter is very simple. You can understand everything. What is important? Sequence, order is important. So I will try to present everything in order. Please you also follow in order. Let us see the standard form of parabola. There is a theorem for that. In descriptive examinations, board examinations, IP examinations, this proof is at most important. So there is every chance of getting this standard form theorem in descriptive examinations. Therefore, listen carefully. Yes. We will see the equation of a parabola in the standard form. For that we have a theorem which is most important. Theorem. The equation of a parabola. The equation of a parabola in the standard form is y square is equal to 4ax, where a is greater than 0. It is a number greater than 0. This is the statement. Now let us understand this statement. What is this? To show that the equation of a parabola in the standard form is y square equal to 4ax. In the statement there is a word standard form. What does it mean? Finding the equation of a parabola in the standard form. What does it mean? Obtain parabola in the standard form. That means nothing will be given. We have to define everything. Generally in theorems, some data will be given. For example, if you take circle, find the equation of a circle with center h comma k and radius r. Then using the given data, we derive the equation. But in the standard form, nothing, no data will be given. We have to define everything. Listen carefully. So the equation of a parabola in the standard form is y square equal to 4ax. This is to be proved. Yes. What is a parabola? We know parabola is a conic. What is a conic? Conic is a locus of a point P satisfying the condition SP by PM equal to E. For parabola, that condition becomes SP by PM equal to 1. So to apply the condition SP by PM equal to 1, what is parabola? It is locus of a point P satisfying this condition. To use this condition, to what is there in the numerator SP? To find SP distance, we need S. P will be there already. Because we are finding the locus of P, therefore we will take capital P as x1, y1. So to find SP we need S. That means focus is to be found first. And what is PM? In the definition we have seen PM is perpendicular distance from the point P to the directrix. Therefore we will also require directrix. So to use the definition, we need focus and directrix. If you define these two, if you get these two, then we can apply the definition of parabola and we can find the equation of the parabola. Listen carefully. So first step, I will explain this steps wise. Listen Nana. In the first step, let S be the focus, L be the directrix of a parabola. I am not writing those steps here, but you watch the video and take a paper, note down all the points in order. Okay. So what is the proof? So we will see the proof now. Yes. First step, let S be the focus, L be the directrix. First step. Next, second one, draw a perpendicular SZ. Draw a perpendicular SZ from focus to directrix. This is second step. Once again, first step is let S be the focus, L be the directrix of a parabola. Nextly, draw perpendicular SZ from focus to directrix. Next, third step. Let A be the midpoint of SZ. Let A be the midpoint of SZ such that AS is equal to AZ is equal to small a. So you take capital A as midpoint of SZ. This is midpoint therefore this portion and this portion will be of same length. There will be some length so I have taken that length as A. That's what I have written. Let A be the midpoint of SZ such that AS and AZ both are equal to small a. Third step is completed. Next, fourth step. Now choose the point capital A as origin. Choose the point capital A as origin and this horizontal line SZ as x-axis. Then automatically the line passing through A parallel to directrix. This one. This is what directrix. The line passing through A parallel to directrix will be automatically y-axis. Once again, listen carefully, very simple. Why I am doing all this? Because we have to obtain the parabola in the standard form. Okay? To obtain the parabola in the standard form, we are in the beginning of the chapter, we know only definition. According to definition, what is a parabola? It is locus of a point P satisfying the condition SP by PM equal to 1. To apply that condition, we need fixed point focus and directrix. Focus is a point, directrix is a line. In coordinate geometry, you take any point or any line, they are all calculated or measured with reference to coordinate axis. That's why I am defining all these. So now what is this? We have taken this point as origin, this line as x-axis, automatically this line is y-axis. Then you can write the coordinates of focus now. What is S? Now S is a point on x-axis at a distance of A from origin. Therefore its coordinates A, 0. What is this? Directrix. It is a line parallel to y-axis. What is the equation of y-axis? Equation of y-axis is x equal to 0. This line is x equal to 0. X equal to 1, x equal to 2, x equal to 3, etc. On the left side, x equal to -1, x equal to -2. Here now directrix is parallel to y-axis at a distance of A on the left side. Therefore, the equation of the directrix is what? X equal to -a. That means x plus a is equal to 0. Yes, we have obtained focus and directrix. Now simply you can apply the definition. So far what we did, once again I will tell you. See in order. When you watch this video, this proof is very important in all the descriptive examinations. You must learn this proof. You watch the video and note it down the points, all the steps clearly. Please listen. First step. Let S be the focus, L be the directrix of a parabola. Step 2. Draw perpendicular SZ from focus to directrix. Step 3. Let A be the midpoint of SZ such that AS is equal to AZ is equal to small a. Step 4. Choose the point capital A as origin and the line SZ as x-axis. Then the line passing through A parallel to directrix will be the y-axis. These are the 4 steps. After completing 4 steps, we could write the coordinates of focus, equation of directrix. Therefore, now what are the coordinates of the focus? A, 0. And the equation of the directrix. What is the equation of the directrix? X equal to -a or x plus a equal to 0. Yes, we have fixed point and fixed line. Focus, directrix, very simple. Now you can find the equation of parabola using definition. Definition says parabola is a locus of a point P satisfying the condition SP by PM equal to 1. Okay. Because it is a locus, we have to take a point on the locus. Let capital P x1 y1 be any point on the parabola which is a locus. Let capital P x1 y1 be any point on the parabola. Say here this is the point. Now by the definition, parabola is a locus. Because it is a conic, it is a locus. For every locus problem there will be a condition. Okay, what is the condition? By definition, the condition is SP by PM is equal to 1, or the condition can be SP equal to PM. What is SP? SP is distance between S and P. What is PM? PM is perpendicular distance from capital P to directrix. This is PM. This perpendicular distance is PM. So we will write what is the distance SP, distance between S and P. This is very simple. x1 minus a whole square plus y1 minus 0 whole square means y1 square. PM means perpendicular distance from x1 y1 to the directrix. We have seen the perpendicular distance in straight lines. Mod ax1 by1 plus c. That means write the point in the line. By root over a square plus b square. What is a? X coefficient in the line. B is y coefficient. There is no y term. So parabola is a locus. We have taken a point, taken condition, written values. Now let us simplify. Squaring on both sides. If you square on both sides, here root will be eliminated. Further I will expand this. If I expand this, a minus b whole square, x1 square plus a square minus 2a x1 plus y1 square. On the right side, denominator is root 1 means 1 only. If you square here, it will be whole square. x1 plus a whole square, which is x1 square plus a square plus 2a x1. I can cut a square x1 square on both sides. We have only one y1 square on the left side. Minus 2a x1. If I write on right side, that becomes plus. Already there is a 2a x1, therefore it becomes 4a x1. That's all. Simplification is over. Since it is a locus problem, in locus problems, finally we have to generalize the problem. That means replacing x1, y1 by x and y, we will be getting the locus. Here what is locus? Locus is parabola. So therefore, finally our conclusion. The equation of a parabola in the standard form is y square is equal to 4ax. What is a here? A is length. It is greater than 0. So this is the equation of the parabola obtained in the standard form. This is standard form of a parabola. Please. Now we have seen the equation of a parabola in the standard form. Firstly, we have seen the definition, then we obtained standard form of a parabola, which is y square equal to 4ax. In that derivation, just we have used the definition and obtained the equation. We did not see the figure. We did not draw the figure of a parabola. Now we will try to draw the figure of this parabola which we have obtained in standard form. Okay. So listen carefully. We have obtained equation now. Now we will see nature of the curve. Nature of the curve. Which curve? Y square is equal to 4ax, which we have obtained in the standard form. Just now we have seen its derivation. This is a parabola in the standard form. Now we will see the nature of this. While deriving this, what we did there, see carefully. In the proof, we took capital S as focus, which is fixed point, and we have taken a fixed line directrix. We have taken in the proof. Also, we have taken a horizontal line SZ as x-axis. Taken a midpoint of SZ capital A. We have chosen this as origin. The line passing through A parallel to directrix. What is this? This is y-axis. Yes, we have done these things now. Right. Now point number 1. Listen carefully. So what is this? What we are doing? Very important. Listen with utmost care. We are discussing the nature of the curve y square equal to 4ax. Only this curve I am discussing. So what is this? It is y square equal to 4ax. Just we have the equation, we obtained the equation, we don't know its figure, nature, etc. Let us try to find those. So what is this? This is parabola. This line is x-axis now. Equation of x-axis is y equal to 0. What is this? Equation of x-axis. Now we will see the line, the curve, whether it is cutting x-axis or not. We will see. For that I will solve these two. Here y equal to 0. If I put y is equal to 0, I will get 4ax equal to 0. 4a is constant. If you write on right side 0 by something 0, x is equal to 0. Listen carefully. By solving x-axis and curve, I got the common point 0, 0, only one point. Listen. Next, number 2. Similarly, by taking the curve, I will take y-axis. What is y-axis? Its equation is x equal to 0. I will solve these two to know their position, how they are. Curve and y-axis, are they cutting, are they touching, how they are. Okay. If I put x equal to 0 in this, y square is equal to x is what? 0. 0 into something 0. What is this? Y square means it is a quadratic equation. How many roots will be there for a quadratic equation? Whenever it has real roots, there should be 2 roots must. Compulsorily it should have 2 roots. Those may be different or equal, doesn't matter, but it should have 2 roots. So y square equal to 0 means, what does it mean? Y is equal to 0 and y is equal to 0 twice. Whenever a quadratic equation is there, it will have 2 roots. Whenever it has real roots, there will be 2 roots. So the roots are equal, that those 2 roots can be equal or different. Here y square equal to 0 means y equal to 0 and y equal to 0. We are solving this and this. By taking x equal to 0, we got y 0. Also second time 0. There is a difference for this and this. Here by solving x-axis and curve directly we got only one common point, one intersection. Here we obtained 2 points, but they are coincident points. Listen carefully. For example, if a curve is there like this, a line is given. A line and this curve, they have 1 point in common. That means like this. You see this? They are having only 1 point in common. This line also having 1 point in common, but there is a lot of difference between these two lines. This line is cutting the curve and this line is touching the curve. So touching means, listen carefully, if you get only 1 point, then the curve will cut the line. So therefore here I can say, by solving x-axis and curve, I obtained only 1 point. Therefore here the curve cuts x-axis. The curve cuts x-axis. Here I got 2 points, but they are coincident points. Therefore the curve, I should say, touches the y-axis. What is the tangent? General definition, meaning of a tangent. We will define like this. What is this? This is a line cutting in 2 points. It is called a secant line. If this point moves on this curve, it will be like this. Then further, when the point reaches this, when 2 points coincide, then the secant line becomes a tangent. That means whenever you get 2 points and the 2 points are same points, then the line is a tangent. Therefore, so what is first point? The curve. This is what? Nature of the curve, y square equal to 4ax. The curve cuts x-axis at 0, 0. At what point? 0, 0. At 0, 0. And the curve touches y-axis at the same point, 0, 0. There is a lot of difference here. Okay. Next you please see third point. So this is what? It is a curve, no? If x comma y is a point on the curve, if x comma y lies on the curve y square equal to 4ax, there can be some points, no? So if x comma y lies on this, then compulsorily x comma minus y also lies on it. See Nana. So what is the curve here? Curve is y square equal to 4ax. I said x comma y is a point on the curve. If x comma y is a point on the curve, it has to satisfy. You substitute in this. This is true because this is lying on this. You substitute this point x comma minus y in the same equation of the curve. Minus y whole square is also y square equal to 4ax. This is true means this is also true. Or you can also say y square is equal to 4ax. So what is y? Y is plus or minus root over this. For every value, every positive value of x, y will have 2 different values. For example, if you take x equal to some positive number, say this entire 4ax is equal to 4, you suppose. What is y? Y is plus or minus 4. Therefore, for every positive x value, there will be 2 y values. So therefore, if x comma y lies on the curve, then x comma minus y also lies on it. What does it mean? See Nana. So x comma y, for example 1 comma 2. If 1 comma 2 is a point on the curve, 1 comma 2 means first quadrant. Definitely 1 comma minus 2 also lies on it. Similarly, for example, if 2 comma 3 lies on the curve, 2 comma minus 3 also lies on it. Many points. If 3 comma 4, then 3 comma minus 4, etc. That means the curve is symmetric about its axis. See, this is the axis. It will be symmetric about its axis. Therefore, what is third point? The curve y square is equal to 4ax is symmetric. Symmetric about its axis or principal axis. For the parabola, line passing through focus perpendicular to directrix is axis. Here x-axis is axis. This is point number 3. Next you take point number 4. The equation of the curve is y square equal to 4ax. From this, y is equal to plus or minus root over 4ax. Okay. Here y is depending on x. Here if I take x greater than 0, if x is greater than 0, entire this quantity will be positive. Square root of a positive number is real. That means y is real. So whenever x is greater than 0, y is real means you will get a real curve. If x is less than 0, this is negative. A is distance, positive, plus into minus, under root of negative number. Under root of negative numbers means not real, imaginary. That means y is not real. So when x is greater than 0, y is real. When x is less than 0, y is not real. What we are doing now? We are discussing the nature of y square equal to 4ax. This is to be noted, point to be noted. Okay. X greater than 0 means this is origin, no? These are all greater than 0, positive values. X less than 0 means this one. Here for x greater than 0, y is real. That means curve is real. Curve is there on the right side of y-axis. For these values, y is not real. That means there is no curve on the left side of y-axis. So the parabola y square equal to 4ax will lie on the right side of y-axis. That is in the first quadrant and third quadrant. Okay. Okay. Next number 5. We will see another. Y square is equal to 4ax is the curve. From this, what is y? Y is plus or minus root over 4ax. So this is applicable. The curve is true for x greater than 0. For positive value of x, you can take positive values. You can take 0.1, 1, 2, 3, 4, etc. You can take any number of terms. So if x is tending to infinity, that is plus infinity, then what about y? Here x is tending to infinity means infinity into something is infinity, square root of infinity also infinity, and plus or minus is there. Already I said for each value of x there will be two y values. For each x value there will be two values. As x, how many values we can take? Any number of values. As x is tending to infinity, y tends to plus infinity and minus infinity. That means the fifth point says that as x is tending to infinity, y also tends to plus infinity, minus infinity. That means the curve is an open curve. There are two types of curves, bounded curve and open curve. Circle is a bounded curve. Bounded curve means whose area can be found. Open curve, area cannot be found. What is this? What is this? With the point 5 we can say that the curve y square equal to 4ax is an open curve. This is open curve. Yes, we have seen the nature of this once again. Why we have seen 5 points here. What point 1 says? The curve cuts x-axis at origin. See Nana, the curve cuts x-axis at origin. Here it is cutting. And point number 2 says that curve touches y-axis at 0, 0. At 0, 0, the curve will touch y-axis. It is cutting x-axis and touching y-axis. Point number 3 says that the curve is symmetric about its axis. This is the axis of the parabola. You should know every term perfectly. What is axis? Line passing through focus perpendicular to directrix. This is the axis. Curve is symmetric about axis means same shape on above the x-axis and below the x-axis. Point number 4 says that curve is real when x greater than 0. Curve lies here only. No curve on the left side. Point number 5 says as x tends to infinity, y tends to plus infinity, minus infinity. So with these we can draw the figure. The figure will be like this. See now, it is an open curve. Symmetric about its axis. This is the equation of the, not equation, figure of the parabola. Which parabola? So far we have studied y square equal to 4ax only. Yes, this is the figure. Parabola y square equal to 4ax will be like this, which is an open figure. Area cannot be found. Yes. We have seen the nature of y square equal to 4ax. Next we will find this length of lattice rectum. Length of the lattice rectum. Length of the lattice rectum of the parabola y square is equal to 4ax. So in the first video we have seen all these principal axis. What is principal axis? What is vertex? What is chord, focal chord, lattice rectum, double ordinate, focal distance, center, focus, directrix, eccentricity. All these are definitions. You must thorough with all those. Okay. Just now we have seen this parabola. No? Its figure will be like this. This is capital A 0, 0. This line is what? Axis. Focus will be here S. And this is what? Directrix. This is Z. Now let us try to find length of the lattice rectum. What is lattice rectum's definition? A focal chord perpendicular to axis. This line is lattice rectum. What is lattice rectum? Focal chord perpendicular to axis. I will suppose L and L dash is lattice rectum. See now. So let L dash be the lattice rectum. Be the lattice rectum. We have to find its length, no? Therefore, and let L dash is of length 2L. That means this length is L, this is also L. Is it true? Yes. Curve is symmetric about x-axis. What is this? Lattice rectum. Lattice rectum is a focal chord perpendicular to axis, which is also a double ordinate. What is a double ordinate? Any chord perpendicular to axis is a double ordinate. Okay. So what will be the distance from this to this? We have taken in the standard form A. Now this is origin, this is x-axis, This line is y-axis. Therefore, can we write the coordinates of L and L dash? Yes. For the point L, this will be x coordinate, which is A. This will be y coordinate L. What will be this point? A comma minus L. Same A, L is in fourth quadrant. This will be A comma 0 and this is A comma minus L. Okay. So both L and L dash, they lie on the curve. So therefore the point capital L, A comma L. This point lies on the curve y square equal to 4ax. If a point lies on a curve, it has to satisfy. Substitute in this. Y square means L square. 4a into x. X is what? A. That becomes a square. So L is equal to 2a. Therefore, what is the length of lattice rectum now? Length of lattice rectum. This is lattice rectum whose length is LL, 2L. 2L is lattice rectum. We have taken it as 2L, but what is L actually? L has come 2A. Therefore, what is this? This is 4A. Therefore, for the parabola y square equal to 4ax, what is the length of the lattice rectum? 4a. Important. In this parabola, this is second degree term, this is first degree term. Coefficient of first degree term will give us, its magnitude will give us length of the lattice rectum. So for this parabola, length of the lattice rectum is what? 4a. Yes. Once again, listen. We have seen the parabola's standard form. Y square is equal to 4ax. This is the equation. Study in order. Go through the all definitions. Listen. We have also seen nature of the curve. So figure will be like this, no? Which figure? Which curve? Y square is equal to 4ax. In the standard form, we have done this. This is capital A. This is capital S. This is directrix. This point is Z. Okay. This discussion now which we are going to do, this discussion is important. Listen carefully. So this is what? Parabola. Which parabola? Y square equal to 4ax. Now we will discuss about this. This is explanation of this. For this parabola, see now, what is its focus? What is its focus? This point is focus, A comma 0. Therefore, for this parabola, focus is A comma 0. Okay. What is this? Directrix, no? What is its directrix? Directrix is a line. This distance is A, seen in the derivation. This is also A. This line is parallel to y-axis on the left side. This is y-axis. See carefully now. Equation of directrix. Directrix is a line x equal to minus a or x plus a equal to 0. Okay. Now we will see the axis. What is the principal axis or simply axis? You should know the definition well. What is axis of a conic? The line passing through focus perpendicular to directrix. Here this is the focus, this is the directrix. The line passing through focus perpendicular to this means this line. What is it? X-axis. Therefore, for this parabola, what is axis? Axis is x-axis. X-axis means whose equation is y equal to 0. Okay, this is axis. Next we will see what is vertex of this. We had a definition of vertex. What is vertex definition? The point where the conic crosses the axis. Here this is the curve. This is the axis. Where it is crossing? Here it is crossing here at the point A. That is known as vertex. Therefore, vertex A is 0, 0. What is this? This is 0, 0 vertex. Here what is y-axis? Y-axis is touching the parabola at 0, 0, which is vertex. Therefore, this line is called tangent at the vertex. Tangent at the vertex. Tangent at the vertex is what? Y-axis. We are discussing all these for which parabola? For parabola y square equal to 4ax. This is important. Y-axis. Y-axis means its equation is x equal to 0. Okay. This is what? Focus, vertex, directrix, tangent at the vertex, and this is axis. For this parabola, what is lattice rectum? Listen carefully. Lattice rectum is what? Focal chord perpendicular to axis. This is lattice rectum, generally denoted by L dash. Just now we have seen what is length of the lattice rectum. Length of the lattice rectum is 4a. This is length of the lattice rectum. See Nana, length of the lattice rectum is 4a. This is of length 4a. And it is a double ordinate. Therefore, this will be 2a and this will be 2a. 2a plus 2a, total its length is 4a. So you should know everything in figure also. For this parabola, see Nana, this is focus, this is vertex, this is directrix. Distance between vertex and focus is a. Distance between vertex and directrix is a. Distance from focus to directrix is 2a, which is equal to semi-lattice rectum. 4a is lattice rectum, half of this, it is called semi-lattice rectum. Distance from focus to directrix is 2a, which is known as semi-lattice rectum, etc. Okay, length of the lattice rectum is 4a, this is 2a, this is 2a, total 4a. This is length of the lattice rectum. Similarly, you can write the equation of lattice rectum. Equation of lattice rectum. What is this? It is a line. Lattice rectum is a line passing through focus, and this is also parallel to y-axis. Any line parallel to y-axis. Y-axis equation is x equal to 0. This is x equal to 0. How much distance? A distance on right side. Therefore, equation of this will be x equal to a. What is this? It was directrix parallel to y-axis at a distance of a on the left side. That's why we have taken x equal to minus a. Further, x plus a equal to 0. Therefore, equation of lattice rectum is x equal to a or x minus a equal to 0. Equation of this. And also, these are called, this is what? L dash. L dash is lattice rectum. This point is L and this point is L dash, no? You can also write the coordinates of these two. What are the coordinates of L? For this, x coordinate is a and y coordinate is 2a. This will be the image of this in x-axis. Same x coordinate but y coordinate is negative. These are ends of lattice rectum. About lattice rectum, we have seen the length of the lattice rectum. What is the length of the lattice rectum? 4a. This is 2a, this is 2a. They are individually called semi-lattice rectum. Equation of lattice rectum x equal to a, and extremities of lattice rectum. Extremities of lattice rectum are a comma 2a, a comma minus 2a. Okay, now see what was the equation? Equation of parabola is y square is equal to 4ax. Okay, for this, what is the axis? Axis is what? X-axis. That means y equal to 0. Listen, always the base of second degree term, this will give us axis. Base of second degree term will give us axis. Tangent at the vertex is y-axis x equal to 0. This first degree term, this will give us tangent at the vertex. Tangent at the vertex. What is vertex? Vertex is where the point where the parabola crosses the axis. This is the vertex. Okay, these are the explanations of all the terms related to the parabola y square equal to 4ax. Yes, in this video what we did order. Firstly, we have seen what is parabola definition. Parabola is a conic for which eccentricity is 1. Or in other words, parabola is a locus of a point P satisfying the condition SP by PM equal to 1. Right. Next, we have taken a theorem. In that theorem, we have obtained the equation of a parabola in the standard form, y square equal to 4ax. After obtaining that equation, after that derivation, we have seen its nature, figure, etc. The parabola y square equal to 4ax, how it behaves, what is its nature, where it cuts x-axis, everything we have seen and we have drawn the figure. It is an open figure. After that, we have find the length of the lattice rectum. Lattice rectum of y square equal to 4ax parabola is 4a. After that, once we have taken this parabola, we have seen everything of this parabola. This is y square equal to 4ax. For this parabola, this point is vertex 0, 0. This point is focus a comma 0. This horizontal line is axis. Parabola is always symmetric about its axis. This y-axis is touching the curve at origin, which is vertex. Therefore, this is tangent at the vertex. This line is directrix. And this line is lattice rectum. L dash is length of the lattice rectum. Length of the lattice rectum is 4a. Its equation is x equal to a. This is 2a and this is 2a. These are extremities of lattice rectum, a comma 2a, a comma minus 2a. In the equation, the base of second degree term will always represent axis of the parabola, and the first degree term will represent tangent at the vertex. So now my suggestion is, you practice all these. First you understand all these points. Definition, derivation, nature of the curve, what is the figure, which point is focus, which point is vertex, what is distance between them. Distance between vertex focus is a, vertex directrix is a, this is 2a, this is 2a, this is 2a. The point is a comma 2a, a comma minus 2a. So what we have discussed, you practice all these number of times. You watch this video, take a notebook, note it down all the points and thoroughly you prepare. In the next video, we will see the various forms of parabola and further. Okay, thank you. Okay.